Welcome to Deep Mentor AI. Today we will talk about the transformative technology of large language models. You've definitely heard the term, but for your UPSC preparation, a deep understanding of them isn't just a good idea, it's absolutely crucial. This technology is everywhere, touching everything from science and tech in GS3 to ethics in GS4. So in this explainer, we're going to break down exactly what you need to know to stay way ahead of the curve.
Okay, so here's our game plan. We've got 5 key areas to cover. We'll kick things off with the basics. You know, the stuff you need for prelims. Then, we'll build up that conceptual clarity that's so important for your mains answers. After that, we'll dive into how they can be used in governance, and we'll wrap up with a really critical look at the challenges and ethics. So let's get started.
All right, first up, let's tackle the fundamentals. Think of this section as your arsenal for the prelims. You know, for those tricky multiple-choice questions where having a precise definition in your head can make all the difference.
At its absolute core, a language model is basically a prediction machine. Think about it. When you're typing, "the sky is," and your phone immediately suggests blue, that's a language model in action. All it's doing is calculating the probability of what word should come next in a sentence. It's a simple idea, but it's incredibly powerful.
So, what's the big deal? What makes a language model large? Well, it really boils down to 3 things. 1, massive scale. 2, an enormous amount of training data. And 3, a really revolutionary architecture called the transformer. These models aren't just guessing the next word anymore. They're doing it with a genuinely staggering understanding of context.
Just look at this number, $175 billion. That's how many parameters are in just one model, GPT-3. For your prelims, a figure like this is perfect. It helps you get a tangible sense of the sheer complexity we're dealing with. This is what allows the model to learn such incredibly intricate patterns in our language.
But what on earth is a parameter? The best way to think about it is like this. Imagine a massive machine with billions and billions of tiny little dials. During its training, the model is constantly tuning each one of these dials, these parameters, to get better and better at predicting the next word. The more dials it has, the more nuanced and complex the connections it can make about the world, all based on the text it reads.
Okay, we've covered the what. Now let's pop the hood and take a look at the engine. Understanding this part is absolutely vital for building the kind of deep conceptual clarity you'll need for those high-scoring mains answers. We're moving from what these models are to how they actually think.
This phrase you see here, "attention is all you need," it's not just a clever title. It's from a research paper back in 2017 that literally turned the world of AI on its head. Before this paper, models had to process text in order, one word at a time. The transformer architecture changed the whole game by letting models look at entire sentences all at once.
And the secret sauce, the real breakthrough here, is a mechanism called self-attention. So forget about reading word by word. A transformer looks at an entire sentence simultaneously. And for every single word, it figures out which other words in the sentence are the most important to its meaning. This creates a much deeper contextual understanding of language.
Let's make this super simple. Take a look at this sentence. How does a machine know what the word "it" refers to? Well, that's self-attention. It calculates the relationship between it and every other word in the sentence, and it correctly figures out that animal is the most relevant one, not street. This ability to resolve ambiguity is really what makes these models so powerful.
So, how do you actually build one of these things? Well, it's basically a 3-step process. First up is pre-training. This is where the model just gulps down a huge portion of the internet to learn grammar, facts, and reasoning. Second is supervised fine-tuning, where humans give it high-quality examples to teach it how to be a helpful assistant. And finally, there's RLHF, which is where human rankers essentially vote on the model's answers to make sure it's helpful, harmless, and aligned with our values.
Okay, so we get how they work, but why does this matter to you as a future policymaker? This next section is packed with solid points that you can pull from directly for your General Studies Paper 3, covering both science and tech and the economy.
You know, the potential impact on governance is just huge. We're talking about AI assistants that can provide 24/7 support to citizens, or models that can summarize thousands of pages of public feedback on a new bill in just minutes. From speeding up legal research in the judiciary to boosting the productivity of India's entire IT sector, the applications you see here are genuinely transformative. And guess what? They're already happening. All right, but here's where we need to get critical, because it is not all sunshine and roses.
To write a really strong, balanced means answer, you have to understand the downsides. And the biggest problem by far is something called hallucination.
Let me just give you a statement. The distance from the Earth to the Moon is 54 million kilometers. Sounds pretty plausible, doesn't it? It's specific. It's delivered with confidence.
But what if I told you an AI wrote that, and that it's completely, utterly wrong? The real distance is only about 384,000 kilometers. That confident, plausible, but totally false statement is a perfect example of an AI hallucination. And this is the single most important thing to remember for your analysis. A hallucination isn't a bug. It's actually a byproduct of how these models are designed. Remember, its job is to predict the most plausible-sounding text, not the most truthful text. It's a world-class pattern matcher, not a fact-checker.
So why does this even happen? Well, there are a few big reasons. It could be trained on bad or biased data from the internet. It's also just doing its core job, predicting words, not finding truth. And sometimes the way we train them actually encourages them to guess rather than just admit, I don't know. There's even a weird phenomenon called the reversal curse, where a model might know that Tom Cruise's mother is Mary Lee Pfeiffer, but if you ask it who Mary Lee Pfeiffer's son is, it gets it wrong.
Okay, let's bring this all home by connecting it directly to security and ethics. These are the kinds of points that will really make your answers in GS3 and GS4 stand out from the crowd. As this tech gets woven into our government and our lives, these challenges become absolutely paramount.
When it comes to security, there are two big attack methods you absolutely need to know. The first is jailbreaking. This is where you trick a model into ignoring its own safety rules, usually by giving it a clever prompt, like telling it to role-play as a character without morals. The other is prompt injection. This one's a bit sneakier. It hijacks the model by hiding malicious instructions inside the data it's supposed to be analyzing, like a web page or a PDF.
And the list of challenges for policymakers doesn't stop there. We're also talking about the risk of data poisoning, where bad actors could sneak malicious data into the training to create a kind of sleeper agent model. Then there's bias amplification, major concerns about data privacy, and of course, the immense energy and computing resources these models need to run.
And that really brings us back to this fundamental idea. This is the first time AI can really handle our messy, unstructured human language at a massive scale. This incredible power, this ability to communicate naturally with machines, is exactly why understanding and managing these risks is one of the most critical challenges facing policymakers today.
So, I want to leave you with this question. A question you should be thinking about for your essays, your interviews, and your future careers. As the people who will be designing public policy, how will you strike that balance? How do you harness this incredible innovation for the public good, while at the same time building the strong guardrails we need to protect our citizens and ensure fairness? We hope this deep dive really helps you get a solid handle on these concepts for your notes. Think deeply about these questions, because they are the future of governance. As always, stay curious. Thanks for joining us.